At 1 atmospheres and 298 Kelvin, pentane is a liquid whereas propane is a gas. Explain. Both molecules are nonpolar, and the only intermolecular forces in each are London dispersion forces. However, pentane is larger than propane and has a more extensive electron cloud that can be involved in a greater number of London interactions, leading to stronger intermolecular attractions overall. Thus, it takes a higher temperature for pentane molecules to have enough kinetic energy, on average, to overcome their stronger intermolecular attractions. Thus, pentane has the higher boiling point. 1 point is earned for recognizing that pentane and propane both have only LDFs. 1 point is earned for recognizing that pentane has a larger electron cloud with greater IMFs and higher BP, reference to state of matter. At 1 atmospheres and 298 Kelvin, methanol is a liquid whereas propane is a gas. Explain. Propane molecules are nonpolar and only interact with one another via London dispersion forces. Methanol molecules are polar and hydrogen bonds, as well as London forces, can form among them. Because hydrogen bonds are stronger than London forces, methanol has greater intermolecular attractions. Thus, it takes a higher temperature for methanol molecules to have enough kinetic energy, on average, to overcome their stronger intermolecular attractions. Thus, methanol has the higher boiling point. 1 point is earned for recognizing that methanol has hydrogen bonding IMFs and propane has LDFs. 1 point is earned for recognizing that hydrogen bonding results in a greater IMF, causing methanol to be a liquid. Indicate the hybridization of the carbon atom in each of the following. 1. Methanol. 2. Methanoic, formic, acid. sp3. 1 point is earned for the correct hybridization. sp2. 1 point is earned for the correct hybridization. Draw the complete Lewis electron-dot diagram for a molecule of propanoic acid, HC₃H₅O₂. 1 point is earned for the correct diagram. All electron pairs must be included. Expected structure: HCH₃CH₂COH showing all single bonds. The C equals O double bond. And 2 lone pairs on each of the 2 oxygen atoms. All octets complete. Explain the following observations about the 2 carbon-oxygen bonds in the methanoate, formate, anion, HCO². You may draw a Lewis electron-dot diagram, or diagrams, of the methanoate ion as part of your explanations. 1. The 2 carbon-oxygen bonds in the methanoate, formate, anion, HCO² have the same length. 2. The length of the carbon-oxygen bonds in the methanoate, formate, anion, HCO² is intermediate between the length of the carbon-oxygen bond in methanol and the length of the carbon-oxygen bond in methanol. Resonance structures can be drawn for the methanoate and ion, with 1 carbon-oxygen bond as a single bond and the other as a double bond, and the opposite in the other structure. The electrons are shared equally between the 2 carbon-oxygen bonds in the methanoate and ion, resulting in 2 bonds with the same length. 1 point is earned for the correct explanation. The 2 identical carbon-oxygen bonds in the methanoate and ion each have a bond order of 1.5. The carbon-oxygen bond in methanol is a single bond, and the carbon-oxygen bond in methanol is a double bond. Single bonds between atoms of the same 2 elements are longer than double bonds, and a bond with a bond order of 1.5 would have a bond length between that of a single bond and that of a double bond. 1 point is earned for the correct explanation comparing the single, double, and resonating bonds of the respective molecules.